Hello everyone, I'm sure you're all awake, I nearly am. I'm Paul Evans, here on Stepan, you know, on Versailles Networks. This is my talk about past, present and future. So we'll start with the past. What do we do in the past, or what people do now? People write code, and their code tends to be a very straight line. You want to do something, you call some functions, turn out to kind of walk in a very straight line, very synchronous. Synchronous basically, you start, you do something, you wait for it to finish, it's now finished, you go on to the next thing. Your code kind of looks like this. Here's a nice simple example. All the examples today are out of balls. You have lots of balls today. So here's our nice little simple function. So we'll start at the bottom. We have our function we call getBall. We're going to wait for it to return here. When it returns, we're going to print the ball. Yay, the ball. That's kind of a bit of a problem with this code, because the function to actually get ball is a bit slow. And that's alright if we're only running one thing once, but maybe we want to run lots of things. And it's very annoying to have to wait for every individual thing to finish, when actually we could be doing multiple things and kind of waiting for lots of things. So we came up with the idea of having goalbacks, asynchronous goalbacks, where we take a piece of code, we wrap it up in a reference, and we pass that reference into a function, and the function kind of looks after it, and calls that reference again later. It's kind of useful, because it means that now you can start multiple things once, and pass in all these callbacks to say what to do when you finish this little thing. Now it's kind of unreadable, because your control flow effectively goes backwards. So here's our asynchronous version of fetching the ball. And so, what I mean by backwards is, here we've created this callback to say what we're going to do when we've got the ball. But we've actually written this code before we call the actual function. So first we say what to do when we've got the ball, and then we ask to actually get it. It kind of feels rather backwards. It also makes it very hard to do more interesting bits of control flow. How else can we solve this? We can use a future. So what is a future? A future is the idea that you return a value from your function that isn't the real value yet, because you haven't got the answer yet. It's a proxy to the real answer that may not be ready yet. It represents an operation that is ongoing and may complete at some point. But until it completes, it hasn't actually got a value yet, but you can still pass it around as a value. You can return it. So here we have some code with some magic, and I will explain what the magic is. But we start off, so we're asking to fetch the ball before we try and print it. The code now reads properly top to bottom again. So this F here, which we put our future in, now represents the idea that we will have a ball in the future. And then, maybe, obviously this example here, we're not actually really making use of it, but in a more interesting example, we could have some other code in between the call to get ball, and later on the method get on the future. And so in between there, we can be doing other things while we're waiting for the ball to arrive. And then eventually the ball arrives, and we can print it. So in fact, I have written a module on Stepan called future, very surprisingly. And this is a really simple example of how we might use that in this ball function. So we construct our future up here, nice and simple. And then we just construct our ball, and we just tell the future, actually it's done immediately. We just call this done method. So we've kind of constructed a future that is now already done, and we've returned it. So this is kind of a little boring simple example, but it kind of demonstrates that we have this idea. Because we could also have done this instead. We've constructed our future, and we've now got this other object called a ball vector. It's going to go off and get the ball eventually. So it's written to this slightly weird backwards asynchronous design where we just pass in a code rep, fair enough. So we have to do that. But we can now wrap the whole idea in this neater version of the future. So we return the future from this function straight away. And at some point later, when the ball fetcher has fetched its ball, it now marks the future as done. So one of the advantages of this shape of code is that we're back to the same kind of shapes that we had with our simple straight line call and return style of code, where this function here doesn't need to consider what's happening next. It's only concerned with what it is doing, which is returning a value. So the code isn't made messy, because if we just go back to our asynchronous one for a moment, the problem with the callback approach is that every function now has to be concerned about what's happening afterwards. It always has to be taking these callbacks to say, what am I doing next? And it turns out that makes a lot of code somewhat messy, somewhat spaghetti shaped, and hard to read. So here's an example of how we'd use this feature. Again, we put in some callbacks because, hey, everybody seems to like callbacks. Because ultimately, you're going to need to do something at the end. So maybe this is how you do it. So maybe you'll ask the future, when you're done, do this thing. It's kind of still a bit messy. It's still a callback, which is kind of messy, but it's one thing you can do. Far neater is you can just tell the future to wait. So the actual future module on CPAN is a sort of an abstract implementation of a future. It doesn't know how to wait. So it actually doesn't have this await method. But the whole thing is designed that you could subclass it. And so if you're working with some kind of event framework or maybe threads or whatever you happen to be doing, you could subclass your future to do whatever is necessary to wait. And so you fetch your future and you kind of do all other types of code. Eventually at some point you're going to need an answer, you need to wait. So you should put a wait on it, and wait till the future's ready. Once it's ready, we can go get and we can print our ball. And in the meantime, we could have done whatever code we like. So all of a sudden we've now just got this very straight line looking code where we just call a function, then we do something with the answer. But in the meantime, we've managed to do other things as well. So we've kind of got this whole parallelism going on in a way that is actually a bit more readable. So other exciting things we can do with futures. So obviously, straight line code, it could return a value or it could throw an exception. So it'd be useful if futures can do this. So these future objects, they have a fail method. So you can try and get this yellow ball, maybe you've got a yellow ball, maybe you haven't. But the function called getBallF may not have finished yet, it may not know whether or not this has succeeded, but it still returns a future anyway. But that future might fail in the future. So what we can do is we can ask the future, has it failed? If it hasn't failed, we can get ball out of it, otherwise we can do something else. Now the reason I put the not there is because actually you can do that instead. Because it's really convenient if the get method actually just throws the exception that it failed with if it had failed. Because it means that you again can just write your nice neat code with these nice little try-catch blocks. Where you try to fetch a future, you try to fetch a ball, maybe it succeeds, maybe it doesn't. If it doesn't succeed, we get the try-catch block. The whole point of the futures is that we're trying to do things concurrently. So we can use this idea that a future object represents an operation that hasn't happened, that hasn't finished yet, is ongoing, and we can start to combine them up. So we can make another future that waits for the other ones. So we try to fetch a red ball, a green ball, and a blue ball, and those all return futures immediately. And then we can wrap them up in another future that's just trying to wait for all of those. So this one $F at the top here is just waiting for all of those three. And we ask for it to wait, and it waits until all three of them are done. And we can fetch the balls out again. So this code here is looking, it's a little bit more complicated. Largely because I've laid out the code to try and fit it on the board. But if we wanted to write this really neatly, we could do my red, blue, green equals future needs all, blah, 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 arrow get. And all of a sudden that looks really similar to my red, green, blue equals get ball, get ball, get ball. It looks really similar to our very simple straight line code, but it's done concurrently. It's really nice and readable. If you tried to do that with an asynchronous code ref taking function, you're going to have to pass in 3 code reps into the 3 different ball functions. And then each one is going to have to check, am I the last one, or are the others waiting and only do the next thing when the last one's all done? And you've got lots of state tracking. It's really messy, very hard to get right. This is really simple. You really can't write that wrong. If you've got futures, you can also have sequences of them. Because we pass in a code ref to the future to say, do this when you're finished. Well, what if that code ref returns the future? Now suddenly we've got a sequence of 2 things. It's a lot neater to handle this exception. Because the problem is, with this code, our little try-catch code, we try to get a ball, try to get the other one. If the get call fails, the try block is going to fail, so we fall into the catch here. But this whole function here is still trying to force this future to happen now. So this piece of code here is not itself going to return a future. So we couldn't wrap that in a larger structure. The whole point here is we're trying to build larger and larger structures out of these things. So we'll rewrite it. So we'll give the future method, we'll give the future object an or else. And we can say, here future, if you fail, do this instead. And whatever that code returns, itself is future. And so now we can wait on that. Of course we can write it even neat like that. Just say f equals get ball or else get unball. Looks pretty similar. It looks almost the same as just using the double pipe or operator. A little bit more messy because you've got the sub word in there, but it's about the best we can do. But it's still really neat. It's a lot neater than you could do with an async, with a callback. So the other neat thing you can do with a future is that you've got a real first-class object that is a real proxy to something that is in progress. You've got a hold of it. You can tell it, actually, I'm fine, I don't need you anymore, you can stop. You can give them a cancel method. So maybe we don't want to wait all day for a ball. So we're going to try and get a ball. Try and get a purple one this time. But we're going to wait. We don't want to wait more than 20 seconds. So here's some code. It's not actually very tidy, but it demonstrates the point. We're going to try and get a ball, wait 20 seconds, ask the thing, are you ready yet? Otherwise, cancel, just give up. It's okay. It's not actually a very nice way to write code. Because the problem is we're going to wait 20 seconds anyway. It's ready immediately. Fine. The other problem is this thing again isn't a future. Let's make it look like a future. So let's have another thing. So we've got our get ball, which is going to return this future that might return more or it might fail. We've got this timeout, which is a tiny little function in whatever event system we're using that returns a future that in 20 seconds time will fail. And then we just wait for the first one to be ready. So this await call is going to sit and wait for either a ball to be ready, or for the fetching of the ball to fail in some deterministic way, or a timeout. And whichever one happens first, wait any is going to cancel the other one. So if the ball is ready, it cancels the timeout. If the timeout happens, it cancels the fetching of the ball. And because wait any is just going to yield the result of whatever thing it was waiting on first yielded, we can again just call this get method. And we can just say, well, try and call get. If we got the ball comes straight out of the get method. If we had a timeout, or getting the ball failed with some kind of exception, the get is going to throw an exception. But this whole thing is still a future, and we can still yield that from other things, and we can build up these nice structures out of them. So that's future. There it is. It's on CPAN. It's called future. So as I said, I'm Evans on CPAN. I'm Leonard on all these various asynchronous. And that's what futures. Oh, one more thing. So I've talked about what we did in the past. I've talked a lot about futures. Haven't talked about the present. Here it is.